going to try something new. I found this app called Show Me, which is a screen and a voice recorder at the same time. So, looking at the notes that I gave you yesterday, this is what we're going to focus on today. The natural log function with integration, and these are the rules we're going to be looking at. If we have an integral of 1 over x dx, then that simply means that it's ln of x plus c. If we have 1 over u du, then that's just simply ln of u plus c. And then you have an alternate form which ties back into u substitution. So let's start going through some examples. Okay, so for example A, what we're going to do first is we're going to pull out a 5, and then we're left with the integral of 1 over x dx. And if you look back at the top of these notes, 1 over x dx is just simply ln of absolute value of x plus c. Don't forget to bring back in your 5 being your constant. Now if you look at example B, you have u, because we got to do u substitution, as our denominator, so x plus 1, and du is just dx, which we have 1 dx already within our integral, so if we integrate it, or rewrite it, 1 over u du, and if you look at the notes, that simply means 1 over, or ln of the absolute value of u plus c. Don't forget to replace u with what you had originally had. So that's really ln of the absolute value, let me write that up here, ln of x plus 1 plus c. Now for part C, you need to simplify that first before you start doing anything else. So you divide x into both x squared and 5. So that's going to give us the integral of x minus 5 over x dx. When we integrate this, that'll be x squared over 2 minus, and then follows example A, 5 natural log of the absolute value of x plus c. And for part D, it's different. So what we're going to do first is we're going to set our u to be ln of x. Our du will be 1 over x dx. So now if we rewrite the integral, that's the integral of 1 over x times, don't forget that with natural logs and exponents, you send them to the front, 1 over 3 ln of x dx. If you look at what your u is, you have that on the bottom of a fraction. Du is going to get rid of the 1 over x and the dx portion. So I'm going to pull out that constant. So I have 1/3 the integral of 1 over u du. We integrate this to be, we're going to integrate this. I needed to erase some so that I could have more space. So it'd be 1/3 ln of absolute value of u plus c. Final answer would be 1/3 ln of u was ln of x plus c, and that would be our final answer for part D. For this next example, they want us to find the area with the log rule. So we've been given this function, y is equal to 2x over x squared plus 1, and it needs to be bounded by the graph, the x-axis and line equals 3. So if we were to actually graph this on the calculator, it would look something like this, x being equal to 3 here, and they want us to find this area. Well, we know that area uses integrals, so it's going to go from 0 to 3 of 2x over x squared plus 1 dx. So u substitution allows us to take the bottom as our u. Du is 2x dx, so we're good. We change our limits. Plugging in 3 to the top one gives us 10. Plugging in 0 gives us 1. So when we rewrite it, we're going from 1 to 10 of 1 over u du. By integrating, that gives us the ln of u, and we're going to evaluate it from 1 to 10. Now here, you do not replace u with what you had set u to be. you changed your limit, so therefore you integrate from here. So then that would give us ln of 10 minus ln of 1, which is 0, and ln of 10 is approximately 2.303. For our next example, we're going to simplify first, dividing x into all of them. That'll give us the integral of x minus 4 plus 5 over x dx. Now when we integrate this, it would give us x squared over 2 minus 4x plus 5 ln of absolute value of x plus c. Now for part B, we have to do something before we can actually integrate it. This, in order for us to divide it into everything, we're going to use synthetic division. Now synthetic division is something you should have learned in Algebra 2, reviewed it in pre-cal, but we're going to go over it anyways. You set the bottom equal to 0 and you set the answer on the outside. You take the leading coefficients of your numerator, so we have 1, negative 3, 2. Bring down your first one, you multiply the outsides, and you add on the inside, and you repeat the process again. So then that gives us 4, that gives us 6. And this last one is considered your remainder. So we're going to integrate this bottom portion. Now our answer is going to be 1 power less than what we started with. So we're going to have x minus 4 plus 6 over what we were dividing by, so x plus 1 dx. So for the first portion, we have x squared over 2 minus 4x. For this portion here, we're going to use u substitution, so it'll be plus 6 ln of x plus 1, and then of course plus our constant. For our last two examples, we're given definite integrals. So again, we start off with our u substitution, 3x plus 1. du is going to be 3 dx, but we don't have a 3, we have a 5 in our integral, so we're going to divide by 3. Divide by 3. We're going to pull out the 5/3. We're going to be left with 1 over u du. Now don't forget to switch out your limits. The top one will now be 13, our bottom one will be 1. We don't have to multiply by any negatives, so that'll give us 5/3 ln of u. We're going to evaluate that from 1 to 13, and that'll give us 5 over 3 ln of 13 as our solution. Now this last example is pretty tricky, so it is a challenge. I had to erase what we had on part A because I needed the space. So what we're going to do first, so we're going to forget this for now because we've already used it. We're going to let u equal our denominator, so 1 plus square root of 2x. We're going to move our 1, so it'll be u minus 1 is equal to the square root of 2x. Take the derivative of both sides, so du will equal to 1 over 2 square root of 2x times the derivative of the inside because it's chain rule, which then simplifies to du is equal to 1 over square root of 2x dx. Well, from here, we're going to send the dx over to the du. So square root of 2x du is equal to dx. Because we don't have a square root of 2 other than the denominator in our problem. So now, if you look at this step here, that's equal to the square root of 2x. We don't want to combine our variables, so we're going to replace square root of 2x with u minus 1 du and set it equal to dx. So now, what we're going to do is we're going to rewrite our integral to be u minus 1 du over u, simplify it, which will give us 1 minus 1 over u du, integrate it, so it'll give us u minus ln of u plus our constant, and now we replace u with what we originally had from here, so that's 1 plus square root of 2x minus ln of 1 plus square root of 2x plus c, and we can combine our like terms being our constants, so we'll end up with square root of 2x minus ln of 1 plus 2x plus c. Let me just finish writing that part off. Square root of 2x minus ln of 1 plus square root of 2x plus c. And that would be our solution.